At 4 o'clock on the afternoon of September 9th, 1991, 4 men reported for shift at the Captain Mine in Perry County, Illinois. Gene Miller climbed into the cab of the machine he'd run for years. Fred Kruger checked hydraulic and oil levels down in the lower works. Gary Andrews, the welder, walked the structure the way he did every day, looking for cracked steel nobody else would notice. A 4th man stayed on the ground with a wheel loader, watching for stray rock in the machine's path. The machine underneath them was the largest shovel ever built, a 15,000-ton mountain of gears and steel called the Captain, and for 26 years it had never once failed to finish a shift. At around 7 that evening, Miller caught a smell that didn't belong. He stopped the machine. He went looking for the source with Kruger beside him. By 5 o'clock the next morning, the Captain was dead. Every gallon of oil built into that machine to keep it running had caught fire in a single night, and by the time the sun came up over the pit, the largest shovel on the planet was a scorched, hollowed-out hulk that would never move another cubic yard of Illinois coal country. Insurance would eventually value the loss at $35 million. Nobody who worked that shift ever fully agreed on what started it. That's the easy part of this story, the ending. The machine burned, and it burned for good. How does something built on this scale, with this much money and this much engineering poured into it, lose to a fire its own crew could see 200 feet away? And why did the company that owned it never really try to find out why? So what actually beat it? A machine engineered to move 300 tons in a single bite, built with enough spare capacity to survive almost anything the ground could throw at it, does not usually lose to a fire that started with a smell one man happened to notice. There's a man in this story who ended up on the gantry, 21 stories in the air, with the ladders gone and the elevator gone and nowhere left to climb. We'll get to him. There's also a number worth holding on to before anything else. The company that owned the Captain got a repair estimate for a fraction of what its insurance eventually paid out for a total loss. Keep that gap in mind. Everything from here forward either explains how a machine like this catches fire or explains why nobody in charge seemed all that interested in stopping that from happening again. Some numbers first, because numbers are the only honest way into a machine like this. The Captain weighed an estimated 15,000 tons, roughly half again as heavy as the entire Eiffel Tower. That's more than double the weight of the next largest stripping shovel ever put to work in North America, a machine called the Silver Spade that weighed a mere 7,200 tons by comparison. The Captain's boom rose 215 feet into the Illinois sky, more than 200 feet of it standing clear above the ground before it even started to dump, with a maximum dumping height of 153 feet. Its dipper, the actual bucket that did the digging, measured 18 feet 6 inches wide, 24 feet 6 inches deep, and 16 feet high. It carried 180 cubic yards of rock and dirt in a single scoop, roughly 300 tons, and it was the only shovel Marion Power Shovel ever built, with 2 separate doors on the bottom of that dipper, each door alone weighing 15 tons. It moved on 8 crawler assemblies, arranged in pairs at each corner, spread across an undercarriage 88 feet wide. Each crawler unit ran 45 feet long and carried 42 individual steel shoes, and each shoe weighed 3¼ tons. Multiply that out, and the Captain was standing on 336 separate slabs of steel, none of them small enough for one man to lift. Running all of it took 20 separate electric motors, 8 for hoisting, 8 for swinging the boom, 4 for crowding the dipper into the bank, and 16 more just for propulsion, pulling enough current to light and heat a town of 30,000 people. The hoist motors alone put out 16,000 horsepower combined, more than 100 ordinary highway trucks running flat out at once, just to lift one dipper full of rock. Every hour it worked, the Captain could move more than 7,000 cubic yards of overburden. Over its life, Arch Minerals' own production records credit it with moving 809,300,000 cubic yards of rock and earth, a number no single shovel or dragline in history has matched before or since. The company that built it charged $25 million for the job, back in 1965. The same year, in the Nevada desert, Caesar's Palace opened its doors in Las Vegas for exactly the same price. One of those two projects still stands. Each corner of the lower frame rested on a vertical hydraulic cylinder 16 feet 9 inches tall and 5.5 feet across, thick enough that a grown man could stand inside the bore. Those 4 cylinders were what let a 15,000-ton machine level itself out over uneven ground, correcting itself degree by degree as it crawled forward at a top speed of 1/4 of 1 mile an hour. It took roughly a year and a half and something like 150,000 man-hours just to bolt the captain together on site, piece by piece, shipped in by rail because nothing this size could travel any other way. And on the night of September 9, 1991, all 15,000 tons of it, every motor and every crawler shoe and every ton of dipper steel, came within hours of being reduced to something the county could sell for scrap. So what finally took it down, if not the rock? It wasn't the weather, and it wasn't age. The captain was only 26 years old, young by the standards of machines this size. What took it down was something the machine had been carrying inside itself the entire time it worked, something every crew who ever ran it knew was there and lived with anyway. We'll get to exactly what that was. For now, sit with the fact that the largest machine ever built to move earth on land didn't fall to the earth at all. In under 10 hours, 20 motors, 336 crawler shoes, and cylinders built to carry more weight than most bridges were reduced to a blackened shell standing over a cracked steel floor plate 5 inches thick. Today, almost nothing of the captain survives anywhere at all, and what little does survive is not what you'd guess. We'll get to that too. That fuel load didn't appear by accident. It traces back decades to a problem that had already killed men underground long before anyone thought to build a machine this size to avoid it. By the 1960s, Illinois sat on some of the richest coal reserves in the country, but much of it lay under enough rock and clay that digging it out from below was slow, expensive, and dangerous. Underground mining in southern Illinois meant tunnels, timber supports, methane, and a death toll that stretched back a century. Strip mining offered a different answer. Peel the overburden off the top in giant slices, expose the seam, and take the coal without sending men underground at all. The catch was scale. The deeper the coal sat, the more rock had to move before a single ton of it could be reached. And by the mid-1960s, the coal under Perry County sat beneath overburden thick enough that existing shovels couldn't keep up with it. William Edward Mullins, Jr., known locally as Bill Mullins, ran Southwestern Illinois Coal Corporation. He'd learned mining first in Henry County, Illinois, then spent time working mines abroad before coming home with strong opinions about how a company should treat both its workers and the land underneath their boots. In 1964, Southwestern opened a new operation near the town of Cutler, the Captain Mine, which would become the largest surface mine east of the Mississippi River. To move overburden fast enough to make a mine that size profitable, Mullins needed a shovel unlike anything the industry had ever ordered. He named that shovel and the mine around it after his father, Thomas C. Mullins, known to his own generation as Captain Mullins, a pioneer of surface mining technology going back to the early part of the century. The order went to Marion Power Shovel Company of Marion, Ohio, a firm that had spent half a century building the biggest excavating machines in the world. What they delivered was, by any measure, the biggest thing they'd ever attempted. A shovel rated at 180 cubic yards, roughly double the capacity of anything Marion had built before it, and more than twice the reach of the Silver Spade, the machine that had briefly held the regional record before the captain arrived. The captain went into service on October 15, 1965, at a construction cost of $25 million, assembled entirely on site because there was no road, rail line, or crane in the country capable of moving it any other way. Miners and executives who worked around it called it, in a phrase that stuck for the rest of its life, the pride and joy of the whole operation. $25 million of engineering went into cylinders, cables, and generator sets built better than almost anything else in the country, and none of it explains yet why a fire that started with one hydraulic leak would eventually beat all of it. The math behind that price tag was simple even if the machine wasn't. A shovel that could clear 100 feet of overburden off a coal seam in 5 days instead of 11 did more than save time. It changed what counted as profitable ground in the first place. Seams that would have sat untouched under too much rock for a smaller shovel to reach economically were suddenly worth mining, which is the entire reason a company would spend $25 million on a single piece of equipment in 1965 and call it a bargain. The captain reshaped the economics of an entire coal region. People often mix the captain up with a different giant excavator built the same era, Big Muskie, a dragline that worked strip mines in Ohio around the same years. The captain used a rigid boom and dipper driven by crowd and hoist motors. Big Muskie swung a bucket on cables instead, dragged across the ground rather than lifted and dumped. They shared a decade and a reputation for scale, and nothing else. Different company, different state, different machine entirely. The captain earned its own record, in its own category, and kept it for the rest of its working life, the largest stripping shovel ever built. When the captain first went to work in 1965, the technical press covered it the way other outlets covered rockets, and engineers from competing coal companies came out to Perry County just to see it move. It was, for a few years, something close to a celebrity in an industry that didn't usually produce any. So how does a machine that famous, that closely watched, end up burning for 10 hours before anyone outside the mine even hears about it? Within a few years, Southwestern itself changed hands. Arch Mineral Corporation bought the company in 1969 and would later become Arch Coal. The paint scheme changed, the letterhead changed, but the captain kept digging, 1-mile-long pit after another, at production numbers no other shovel in the world could match. By the time Arch Coal owned it, the captain had become something close to a local landmark, visible for miles across flat farm country, a machine kids in Perry County grew up believing looked like something out of science fiction. None of that explains how it worked. And understanding how it worked means answering a much more basic question first. How do you keep 15,000 tons from tipping over its own dipper? A machine that heavy does not simply sit on the ground and dig. Set 15,000 tons down on ordinary soil and start swinging a 300-ton dipper off one side of it, and the whole thing tips, or sinks, or both. So the captain's entire lower structure was built around one job, keeping that weight distributed and level no matter what the ground underneath it was doing. 8 crawler units, paired at each corner, spread the load across dozens of steel shoes. At each of the 4 corners, a hydraulic cylinder, 16 feet 9 inches tall, lifted and lowered that corner independently, constantly correcting the machine's balance as it crept forward. Without that system working exactly right, at exactly the right pressure, at every second the machine was moving or digging, the captain simply could not function. That system was the reason the machine could exist at all. That balancing act was the single hardest problem anyone at Marion Power Shovel had to solve. Harder than the motors, harder than the boom. Every stripping shovel before the captain had been small enough that its own crawlers could carry its weight without much correction. At 15,000 tons, distributed unevenly every time the boom swung a loaded dipper out over one side of the machine, the captain had no such luxury. Tip the balance too far in the wrong direction, while 300 tons hung off the end of a 200-foot boom, and there was no recovering from it. The 4 leveling cylinders existed to solve exactly that problem, reading the tilt of the frame and correcting it in real time, continuously, for every second the machine was in motion. It was the kind of solution that only works if the hydraulics behind it never fail, which meant the machine's single greatest safety system and its single greatest fire risk were, from the day it was built, the exact same 8,000 gallons of oil. Above the crawlers sat the revolving frame, a slab of steel 5 inches thick that carried the entire upper machine, the house, the boom, and the dipper, and let it all rotate independently of the tracks below. The digging cycle itself followed a simple sequence repeated thousands of times a day. Current flowed into the hoist motors, which drew the dipper up the face of the pit on steel cable thick enough to anchor a ship, while the crowd motors pushed the dipper arm forward along the boom, driving its teeth into the rock and dirt. Once the dipper was full, up to 300 tons in a single pass, enough rock and soil to bury a 2-story house, the swing motors rotated the entire upper house around on the revolving frame, carried the load out over the spoil pile, and the operator tripped the dipper doors open from the cab. Repeat that 7,000 times an hour, every hour of every shift, and it starts to make sense why a machine like this needed 20 separate motors just to keep the cycle moving without ever fully stopping. All of it ran on 14,000-volt alternating current, stepped down through 4 separate motor generator sets housed inside the machine itself. Put together, the captain drew more electricity at peak output than a town of 30,000 people. None of those electric motors could survive direct exposure to the load they were driving. Every joint that needed to move smoothly under that kind of weight, the crawler cylinders, the crowd mechanism, the leveling and steering systems that kept the whole lower frame stable, ran on hydraulic fluid instead of raw mechanical force, because hydraulics could deliver precise, controllable pressure that gears alone couldn't. The captain carried 8,000 gallons of that hydraulic fluid, circulating constantly through steel lines and rubber hoses under high pressure, inches from electrical relay panels, motor housings, and switchgear running 14,000 volts. On top of that, the machine carried a 1,000-gallon diesel tank for its auxiliary systems, 1,000 pounds of grease cycling through an automatic lubrication system that kept every bearing and gear tooth from grinding itself apart, and 1,000 gallons of solvent stored in drums for cleaning parts during maintenance. The system that let the captain move at all was also, by necessity, one of the largest concentrations of flammable liquid on any single machine in American industrial history. Every stripping shovel of this era carried some version of the same setup. High-pressure hydraulics living next to high-voltage electricity is simply how a machine this size gets built. Crews and engineers understood the risk. It's why the captain was fitted with dozens of 20-pound dry chemical fire extinguishers, positioned all over the structure, at every level a man might need to reach one in a hurry. Nobody who built or ran the captain was pretending the danger wasn't there. What none of them fully reckoned with was how fast that danger could outrun the extinguishers meant to stop it. What happens when 8,000 gallons of pressurized oil finally finds a spark it can't be stopped from finding? That risk didn't shut the captain down. It ran anyway, every day for 26 years, and the 4 men who climbed onto it, each shift knew exactly what they were climbing onto. The captain mine ran 3 shifts around the clock, and the shovel itself needed a 4-man crew, every one of them. An operator up in the cab controlling hoist, crowd, and swing. An oiler responsible for keeping every one of those hydraulic and lubrication systems running clean. A welder who patrolled the structure looking for cracked steel and fixed what he found, often while the machine kept working underneath him. And a ground man who handled the trailing power cable and drove a wheel loader to clear stray rock from the crawler's path. On the afternoon shift of September 9, 1991, 4 p.m. to midnight, that crew was Gene Miller in the cab, Fred Kruger as oiler, Gary Andrews as welder, and a 4th man on the ground. That 3-shift rhythm meant the captain almost never stood still. Production targets were set around the assumption that the shovel worked around the clock every day the weather and maintenance allowed. Whatever crew clocked in inherited whatever condition the machine was in when the last crew clocked out, cracked welds and worn fittings included. You don't just walk up to a machine like this and start work. You climb. Getting from the ground to the operator's cab meant ladders and stairwells running up through a house the size of a small office building, past electrical rooms running 14,000 volts, past the gear cases and motor housings that made up the swing and hoist systems, up to a cab that sat roughly 200 feet above the pit floor by the time you reached the boom. From there, if you needed to reach the top of the boom itself, and Andrews, as welder, sometimes did, there was another 100 feet of structure above that, reached mostly by internal ladders and, when those failed, by walking the boom's suspension cables directly. Nothing about this job happened at ground level for very long. Picture it for a moment from below. You're standing at the base of a machine taller than a 20-story building, and somewhere near the top of it, on a beam not much wider than a sidewalk, a man is doing routine maintenance with nothing under his boots but 200 feet of open Illinois sky. What happens to that man the one day something up there fails? You get used to it, the way anyone gets used to heights and heat and noise they can't avoid. You stop noticing the 200 feet. That's not recklessness. That's just what the job looked like on a machine built at a scale nobody else in the world had attempted. The daily reality of running the Captain was constant noise and constant heat, the groan of 20 electric motors working in sequence, and the shriek of steel dipper teeth tearing into rock. The whole structure shuddered every time 300 tons of overburden dropped into the dipper. Dust from the pit hung permanently in the air, and in summer the machine house trapped heat from 20 running motors on top of Illinois humidity that was already brutal on its own. Maintenance never really stopped, because a machine built almost entirely from custom parts, nothing off a shelf, nothing interchangeable with a smaller shovel, couldn't afford to sit idle waiting on a replacement to ship. When something broke, somebody climbed up and fixed it, often standing on structure with nothing below but a couple 100 feet of open air. Gary Andrews had spent years as that somebody. As the crew's welder, his job put him in more of the machine's dangerous corners than anyone else on the shift. Up in the gantry, out along the boom, down in the lower works where the hydraulic lines ran. He knew the Captain's structure the way a mechanic knows an engine he's rebuilt a dozen times, which meant he also knew exactly how far a man could get from solid ground on this particular machine before there was nowhere left to climb. None of the crew talked about it in dramatic terms, because for them it wasn't dramatic, it was just the job. A cracked weld on a crawler shoe meant climbing down into the lower works with a torch and a rod while the machine sat idle, and every hour of downtime cost the company money it wanted back. A gear case running hot meant someone crawling into a space barely wide enough for a man's shoulders, wrench in hand, next to components that could take a finger off if they moved wrong. The crew that ran the Captain treated a 200-foot climb the way an office worker treats a flight of stairs, because they made that climb, or one like it, most days of their working lives. It was ordinary right up until the night it wasn't. Late summer evenings in Perry County settle in slow. The light goes gold over the spoil piles around 6. The air cools a few degrees, and out past the pit, the flat farm country of southern Illinois stretches quiet in every direction. It was that kind of evening on September 9, 1991, ordinary, unremarkable, the kind of shift change nobody would have written down anywhere if what happened next hadn't happened. Every shift began the same unremarkable way. The 4 p.m. crew clocked in, climbed to their stations, and the Captain went back to work exactly as it had every day since October 1965. Swinging its dipper through the overburden, dumping load after load onto the spoil pile, keeping pace with a bucket wheel excavator working the same pit a few 100 yards away. September 9, 1991 started that way too. Nothing about the first 3 hours of the shift suggested it would be any different from the 10,000 shifts that came before it. It wasn't, for the first 3 hours. Then, at about 7 o'clock, in his usual seat in the cab, Gene Miller caught a smell that didn't belong. Miller stopped the machine and swung down from the cab with Kruger right behind him. A burning smell on a machine like this could mean almost anything. A brake shoe sticking, an overheated bearing, a short somewhere in miles of internal wiring. So the two of them worked through the machine systematically, checking the house first before they found what they were looking for. Nothing there. They kept moving, down through the levels of the structure, following a smell that got stronger with every landing. Then they saw it, smoke curling up out of the lower works, down where the crawlers and the hydraulic cylinders lived. in the one section of the machine soaked in 8,000 gallons of pressurized oil. When they got down to it, they found hydraulic oil already burning, low and fast along the steel floor of the lower frame, in a space built to be tight, enclosed, and full of exactly the fuel a fire needs. Andrews joined them within minutes, and all three men went at the fire with what they had on hand. 20-pound dry chemical extinguishers, mounted in racks all over the machine for exactly this reason. There were dozens of them positioned at different levels of the structure, and the crew emptied them as fast as they could reach the next one. It wasn't enough. The fire kept growing faster than three men with hand extinguishers could keep up with, feeding on a hydraulic system built to hold 8,000 gallons of fuel for exactly the kind of movement that had made the captain worth $25 million in the first place. Miller made the call to the mine office. Andrews headed for the elevator, going up to the roof of the machine house to bring down whatever extinguishers were stored there. He made that trip 3 times. On the third climb, the smoke inside the house had turned thick and black, filling the space so completely he couldn't see his own hands in front of him. By the time he reached the roof again, smoke was pouring up the elevator shaft behind him, which meant the elevator was no longer an option for getting back down. Kruger and the fourth crewman had already gone down by the exterior ladders while Andrews was still climbing. Now those ladders ran straight through zones the fire had already claimed. Andrews was alone on top of the machine house, with the fire building underneath him and no way down. He waited to see whether a rough-terrain crane with a man basket, one of the first pieces of outside equipment to reach the scene, could get high enough to lift him off. It couldn't. The roof kept getting hotter. Where do you go when the roof is out and the ground is out? With nowhere else to go, Andrews climbed higher still, up onto the gantry structure above the house, the framework supporting the boom's suspension cables, putting himself roughly 210 feet above the pit floor, 21 stories up, on a machine that was actively on fire underneath him. The mine's own fire trucks arrived first, carrying 200-pound dry chemical extinguishers that turned out to be nearly useless against a fire burning 30 feet off the ground, out of any reasonable reach. Putting a man on the structure to fight it directly was ruled unsafe. How do you fight a fire on a machine that has no walls and no front door? A fire on an ordinary building follows rules firefighters train for their whole careers. A known footprint, doors and hallways, walls that hold water, and hoses that reach every floor from outside. None of that applied to the captain. The fire wasn't burning inside a structure with 4 accessible sides at ground level. It was burning inside the guts of a machine standing on a bench 25 feet above the pit floor, wrapped in steel plating that had to be reached from underneath and around, with no stairwell built for a hose line and no fire doors to hold a blaze in one section. Every piece of equipment on scene, ladder trucks, hand lines, even the mine's own extinguishers, had been designed with a human-scaled building in mind. Fighting a fire inside a 15,000-ton machine burning from the inside out was a different problem entirely, and there was no manual anywhere for solving it from the ground. At 9:44 p.m., close to 3 hours after Miller first caught that smell, the mine office finally called the Cutler Fire Protection District for outside help. Fire Chief Larry Bennett took the call and immediately started working the phones himself, pulling in brigades from Pinckneyville, Percy, Campbell Hill, Steelville, Coulterville, DuQuoin, and Sparta. Before the night was over, 7 different fire departments, including Pinckneyville's Jim Gilo, were fighting a blaze on a single machine in a coal pit in rural Illinois. The first half hour after Bennett arrived was, by his own account, close to chaos. Mine employees on shift tried to direct the response themselves, giving instructions that conflicted with what the arriving fire crews were doing, without the authority to pull in the equipment the scene actually needed. 7 fire departments were converging on a mine complex most of them had never worked before, in the dark, trying to find a machine standing on a bench 25 feet above the pit floor with no paved road built for a fire truck. In the confusion, one of the mine's own foremen drove off the edge of the coal seam and rolled his truck. He walked away from it, but the accident cost minutes nobody had to spare. It took real time to get a working command structure in place. Eventually, a command post was set up inside the Steelville Department's emergency vehicle, coordinating fire brigades, mine-supplied water tankers, lifting equipment, and a boom truck fitted with its own man basket. All of it staged on the bench above the pit, while the captain burned below. The plan that finally took shape was simple in concept and brutal in scale. Get a water supply running and use a deluge gun to cool the superheated steel before it warped or gave way entirely. An aerial ladder went up, but it couldn't reach anywhere near where Andrews had climbed to escape the smoke. Bennett later described what the fire looked like from the ground, the flames rolling out around the lower frame 30 feet up, and he put it about as plainly as anyone could. It looked like the largest pot you have ever seen sitting on it. Getting Andrews down took more nerve than any piece of equipment on scene that night. Miller talked him into strapping on a safety harness and clipping it onto one of the boom's suspension cables, 2-inch steel rope running from the top of the gantry all the way out to the top of the boom itself. Andrews worked his way hand over hand along that cable in the dark, 21 stories above a burning machine, unclipping and reclipping his harness at every stabilizer block separating one length of cable from the next, until he reached the top of the boom, where he could finally climb down the boom's internal steps to a point the man basket could reach. From there, at last, he was lifted down. Miller himself had gone up partway along the same cables to reach him and talk him through it, which meant Miller now needed help getting down too. Fred Kruger rode the man basket up, walked out to meet him, and helped him make the climb back to solid ground. By the time the last man was off the structure, it was full dark, and Bennett's crews kept working the deluge guns through the night, pouring water on steel that had been superheated for hours. Miller stayed 3 hours past the end of his shift, watching his machine burn. By around 2 in the morning, 7 hours after he'd first caught that smell, the fire looked to be nearly out, the flames down to a smolder, the worst of it apparently over. Was it, though? Then the heat that had been building inside the swing gear cases the entire time finally did what heat like that does. It melted the seals holding those gear cases together, and oil that had been trapped and superheated for 7 straight hours came pouring out directly into what was left of the fire. Men who had been watching the flames die out watched them come roaring back instead. The captain reignited and burned for 3 more hours before firefighters finally put it out for good. A little before 5 in the morning, almost 10 hours after Gene Miller first noticed a smell that didn't belong. The captain was finally completely out. What was left standing in the Illinois dawn didn't look, at first glance, like a machine that had almost taken a man's life a few hours earlier. When the sun came up and Miller could finally see the captain in daylight, the damage looked almost survivable. From a distance, it seemed close to normal. Some blackened panels near the bottom of the house, a few missing steel plates, nothing that screamed catastrophe. Climbing up into the machinery house and the cab itself, everything looked essentially untouched except for a heavy layer of smoke residue coating every surface. For a short while, it looked like the story might end with a repair bill and a few weeks of downtime. The mine couldn't afford to wait and see. The captain worked in the same pit as a Bucyrus Erie bucket wheel excavator, 700 feet long and more than 5,000 tons on its own, a machine that depended on the captain clearing overburden ahead of it to keep working at all. Without the shovel, that excavator, along with the drills, loaders, trucks, and coal shovels supporting it, would run out of ground to work within days. So even before anyone had finished assessing what the fire had actually done to the captain, Arch Mineral had Miller leading a separate team to revive a smaller shovel, a Marion 5900 sitting idle at the company's nearby Leahy mine, and prepare it to take over. That decision, made almost immediately before the full damage report existed, says something about how replaceable the company already considered the record holder to be. Then came the inspection that mattered. A closer look at the lower frame showed the fire hadn't just scorched surfaces, it had burned for hours, feeding directly on hydraulic oil from the steering and leveling systems that kept the captain's 15,000 tons balanced and moving. The main revolving frame, the steel plate carrying the entire upper machine, showed a crack running clean across its full width, through 5 inches of solid steel, almost certainly caused by firefighters' water hitting metal that had been superheated for hours. A machine engineered to survive rock, weather, and its own 300-ton dipper had a fracture running through the one piece of steel everything else in it depended on. Marion Power Shovel Company, the same firm that built the Captain 26 years earlier, put a number on fixing it: $7 million. Could the largest shovel ever built actually have been saved? That figure covered replacing the cracked revolving frame plate, rebuilding the lower works, and restoring the hydraulic and electrical systems the fire had gutted. It did not, by any account on record, describe a machine that was beyond saving. Marion's own engineers had built the thing once already, and they were telling Arch Cole it could be built back a second time for well under a third of what the insurance would eventually pay out. Arch Cole reviewed that estimate against the fact that a working replacement was already being prepared and made its decision. The Captain would not be repaired. A contract went to United Salvage Company of Illinois, and through 1992, piece by piece, the largest shovel ever built was cut apart and hauled away, dismantled in the same pit it had spent 26 years digging. The insurance math is the part of this story that's hardest to leave alone. The Captain had been insured through Lloyd's of London, and after adjusters reviewed the loss, Arch Mineral accepted a payout of $35 million for the machine. $7 million would have put the Captain back to work. $35 million is what the company took instead, walking away from a machine that had just set a production record no other shovel in history has matched. Nobody involved has ever had to explain, on the record, why a 5 times gap between repair cost and settlement value didn't raise more questions at the time. Why wouldn't it? In the decades since, a persistent rumor has circulated among people who worked at the mine that the fire wasn't purely an accident, that the numbers lined up too conveniently for a company sitting on an aging machine and a very large insurance policy. No evidence has ever surfaced to support that theory beyond the coincidence of the math itself, and nobody has ever been able to point to more than suspicion. The rumor never fully died, and neither did the question underneath it, because the actual cause of the fire was never nailed down either. Which was it, the rags or the hose? Miller, who spent more hours in that cab than almost anyone alive, said as much directly. The exact ignition point was never conclusively identified. One working theory pointed to oily rags left in the hydraulic room, ignited by sparks off a nearby electric motor. Another pointed to a leaking hydraulic hose spraying a fine mist of oil into the air, a mist that needed only the same kind of spark to catch. Both theories fit everything the crew found that night. Neither one was ever proven over the other. A $25 million machine, the largest of its kind ever built, burned to a total loss, and the official record closes on a shrug. 30 years after the fire, a local historian named Will Stevens set out to track down as many of the people who had been there as he could find, and recorded their accounts before those memories disappeared for good. What he collected confirms the shape of the story, the smell, the extinguishers, the man on the gantry. It also confirms that the insurance rumor is still alive in Perry County, even without a shred of hard evidence behind it. Nobody has ever proven the fire was anything other than exactly what Gene Miller said it was: an accident nobody could pin down, on a machine that carried its own accelerant every day it worked. What the Captain left behind, in the numbers that do exist, is a production record that still stands. Over 26 years, it moved 809,300,000 cubic yards of overburden, more than any single shovel or dragline in history, before or since. Miller himself put the difference in terms that are hard to argue with. On the Captain, his crew regularly dug a complete pit a mile long, end to end, in 10 days, and turned in production numbers above 7,000 cubic yards an hour doing it. In the east half of that same pit, where the overburden ran 100 feet deep, the Captain finished the job in 5 days flat. When the smaller Marion 5900 took over that same stretch of ground after the fire, the same work took 11. 2 shovels, 1 job, more than double the time. There was only ever one captain. The land itself outlived the machine by decades. 16,000 acres of the old Captain Mine complex were eventually reclaimed and folded into Pyramid State Recreation Area, one of the largest state parks in Illinois, where deer now cross ground that crawler tracks once dug into ridges deep enough to swallow a truck. Illinois law required the mining company to restore that ground to something close to its original contour, and decades later hunters and hikers use the same fields the captain once tore apart in 300-ton bites. One section of the park still carries the captain's name. As for the machine itself, almost none of it made it past 1992, cut apart and sold off as scrap steel, cab, dipper, and all 20 motors included. By one account from a man who worked there, the single thing anyone ever thought to keep from the largest shovel ever built had nothing to do with steel. It was the flag that had been flying above the machine house on the day it caught fire. Both Miller and Andrews made it down alive that night, and both were still telling the story decades later, when a magazine writer and then a local historian came looking for the people who'd actually been there. Neither of them, 25 years on, had ever gotten a straight answer for why the fire started. Neither had anyone else. 26 years, 800 million cubic yards, a fire nobody could fully explain, and a repair bill nobody with the money to pay it ever really wanted paid. So what actually killed the largest shovel ever built? The same 8,000 gallons of oil that had let it move 300 tons in a single bite for 26 years, and a company that decided, in the end, $35 million was worth more than fixing it.